Good day, students. In this video, we're going to look at chromatography. I suppose your teacher or in your class you've discussed about several methods which are called separation techniques. It could be filtration, it could be evaporation, it could be distillation, fractional distillation. But chromatography is one of the physical methods that we can use to separate substances. Now, in chromatography, we can be separating a mixture of soluble substances using a known solvent. In other words, what you see on the board here is the result of the chromatography experiment. The diagram that we come up with is called a chromatogram. So this is a chromatogram showing a mixture of two amino acids. They've been dipped in a solvent, and the starting point is shown by point X, and after some time the amino acids are going to move up the chromatograph paper. When you come to A level, new terms will be introduced to you, like the stationary phase, the mobile phase. So in this case, the mobile phase is our solvent. It's carrying up the two amino acids, and also the stationary phase is our chromatograph paper. But at Igcse level, we just talk about the chromatograph paper and the chromatogram as a way of separating two amino acids that have been mixed. So what questions can we get from this diagram? You see there's this distance 10 centimeters, okay? This is the distance that is going to be traveled by the solvent. So the top part that you see here, we call it the solvent front, where our solvent is going to end. We call it the solvent front, okay? And 4 centimeters is the distance traveled by amino acid A, and 6 centimeters is the distance traveled by amino acid B. You could be asked to calculate RF value for amino acid A. Whenever you're calculating RF value, the thing is you should always get a fraction, because the formula for RF value, you're going to look at the distance, okay, traveled by solvent, the distance traveled by solid, which is your amino acid, over distance traveled by solvent, okay? So why I'm saying you're going to get a fraction is that the distance traveled by the solvent is the denominator, is going to be a bigger number, and the distance traveled by the solid is going to be a smaller number. For instance, RF value for A, okay? For A, you're going to say A travels only 4 centimeters, and your solvent is going to travel 10 centimeters. So your RF value is going to be 0.4, okay? No units, because we are looking at both centimeters. So the RF value for amino acid A is going to be 4 centimeters. And also, if you look at the RF value for B, it's going to be 6/10, and we are going to get 0.6. So what do we do after this? There is always a reference chart that we use for amino acid in this solvent, and then you look up the values. You'll be in a position to know which is the amino acid you're looking at. And also, after this experiment, amino acids are colorless, so you have to spray what you call a locating agent, and it could be ninihydrin, okay, to have color. After you carry out your chromatography, you're going to have a paper which has no spots at all. So what you do is to spray ninihydrin to locate the substances. So your ninihydrin, we call it a locating agent, okay? So in short, that is what I had for you today, the technique called the chromatography and how we can use it to calculate RF value. Thank you. Have a good day.